Welcome to our deep dive into the world of artificial intelligence.
AI.
Yeah,
AI.
it's everywhere these days.
Today we're going to be exploring what AI really is,
Like, what's actually going on under the hood?
how it works now, stuff that's already impacting your life, whether you realize it or not,
And where the hype ends and reality begins?
because there's a lot of hype.
So much hype.
Yeah.
Our guide for this journey is a book by Melanie Mitchell
Oh yeah, she's great.
called NUW Artificial Intelligence, a guide for thinking humans. She wrote it back in 2019.
Yeah.
But it's surprisingly relevant because she digs into these fundamental challenges that AI is still facing today.
It's not like she's got all the answers or anything,
No.
but she really lays out like what the big questions are,
Yeah.
and like the different ways people are trying to answer them.
Yeah, and one of the first things she does is ask this question. How terrified should we be about AI, really?
That's the million-dollar question, isn't it?
Yeah, it is. And we see these headlines every other day about AI achieving something incredible or posing some existential threat.
Right, like it's either gonna save us all or destroy us all.
So let's unpack this a little bit.
Let's dive in.
Mitchell starts off by highlighting that even defining intelligence is tricky.
Yeah, that's true for humans too, let alone machines.
Yeah, like you would think we'd have that figured out by now.
You'd think so, but it's way more complicated than it seems.
And then, of course, artificial intelligence even more so.
Right, because you're adding this whole other layer of like, what does it mean for something to be artificial?
And this isn't just like philosophical nitpicking.
Right, it actually matters.
It impacts how we measure AI progress and what goals we set.
Like, how do we even know if we're making progress if we can't agree on what we're aiming for?
Exactly.
And think about it, even with human intelligence, we measure it in all sorts of different ways.
Right.
Like we have IQ tests, but then we also talk about different types of intelligence.
Like emotional intelligence or something.
Exactly, like verbal intelligence, spatial intelligence, the list goes on and on.
So it's not just one thing.
Nope. And AI is kind of the same way, it's multifaceted.
Okay, so then Mitchell throws in this idea of the anarchy of methods problem,
Oh yeah, that's a good one.
which basically means that AI isn't just one unified field.
Right, it's not like everyone's working on the same thing in the same way
Different approaches have existed since the very beginning.
from the get-go.
And get this, they're still debating which is best.
Yeah, there's no clear winner.
It's like, imagine physicists arguing about whether gravity exists.
I mean, they kind of do that sometimes, but
Well, okay, bad example, but you get the idea.
right, it's like fundamental disagreements about the best way to do AI.
Okay, so tell me about these different approaches.
Well, two main camps emerged at this very first AI workshop
Where was that?
at Dartmouth back in 1956.
Okay, so like the dawn of the computer age.
Pretty much. Yeah.
So what were these two camps?
One was called symbolic AI,
Okay, symbolic AI,
and the other was subsymbolic AI.
sub-symbolic, got it.
Okay, so symbolic AI is all about programming explicit rules and knowledge into a computer.
So it's like teaching it logic or something.
Exactly like teaching it how to solve logic puzzles.
Uh-huh.
And one of the early test cases for symbolic AI was this thing called the missionaries and cannibals problem.
Okay, that sounds kind of ominous.
It is a little bit morbid. It's this classic logic puzzle where you have to figure out how to move missionaries and cannibals across a river
Okay.
without anyone getting eaten.
Oh, I see.
So it's like you have a boat
Uh-huh.
and you can only fit a certain number of people in it.
Okay.
And you have to make sure there are never more cannibals than missionaries on either side of the river.
Sounds tricky.
Yeah, it's a good test of like logical reasoning and planning
So that was like an early attempt to make AI think logically.
in a very specific way. Yeah.
Okay, so what about this other camp, sub-symbolic AI?
So subsymbolic AI takes a totally different approach.
Okay.
It's all about mimicking the structure of the brain.
Like literally like the physical structure.
Well, specifically neural networks,
Right.
which are these interconnected nodes that are kind of like the neurons in our brains.
Okay, I see.
And the idea is to let the network learn from data.
So instead of programming in the rules, you just give it a bunch of data and let it figure it out.
Exactly, like kind of like how our brains learn through experience.
Right?
Like we don't start out knowing everything we have to learn by observing and interacting with the world.
So it's more about like training than programming.
In a way, yeah.
Interesting.
And this contrast between symbolic and subsymbolic AI is really key because
Okay.
it highlights these two fundamentally different approaches to creating artificial intelligence.
Right, like are we trying to build a brain or are we trying to program a mind?
That's a good way to put it.
And which one is winning?
Well, that's the thing. They're both still around.
Still duking it out after all these years.
Yeah, it's a debate that's still raging on today.
Wow. So even the very foundation of AI is up for debate.
Pretty much.
But did either of these approaches actually work?
Well, that's a good question.
Because Mitchell takes us back to the 1970s.
Ah, yes.
When AI hit a bit of a rough patch.
The first AI winter.
The AI winter, what happened?
Well, basically, AI hadn't quite delivered on its early promises. You know,
Right.
there was all this hype about how AI was going to revolutionize everything.
Right.
But it turned out to be a lot harder than people thought.
So what happened? Did people just give up?
Not entirely, but there was definitely a sense of disillusionment.
Okay.
And funding started to dry up.
Makes sense if it's not delivering.
Right.
So did anyone try to figure out why it wasn't working?
Yeah, there was this report called the Lighthill Report,
The Lighthill Report.
published in the UK in 1973.
Okay.
And it basically said that experts had lost faith in the idea of creating a truly general-purpose program.
Okay, so what's a general purpose program?
It's basically a program that could learn and adapt like a human brain across different areas.
So not just good at one specific thing,
Right, like not just playing chess or translating languages.
but something that could learn and solve problems in any domain.
Exactly, like a truly intelligent machine.
And the Lighthill Report was basically saying that's not going to happen.
Not anytime soon, at least.
So the dream of creating a truly intelligent machine seemed further away than ever.
It definitely felt that way.
But wait a minute, I thought you said AI is booming now.
It is, but it took a while to get there.
So what changed?
Well, amidst this AI winter, a glimmer of hope emerged in the 1980s.
Okay, what happened?
The rise of connectionism.
Connectionism, that sounds familiar.
It's related to those neural networks we talked about earlier.
Ah, okay, so it's like the sub-symbolic AI approach was making a comeback?
Yeah, exactly.
So what's connectionism all about?
It's basically a type of sub-symbolic AI that's directly inspired by the structure of the brain
Okay.
and how it learns from connections between neurons.
So it's like they were trying to actually build a brain in the computer,
Kinda.
and did it work?
Well, it led to renewed interest in neural networks and their potential for learning and problem solving.
So things were looking up again.
For a little while, yeah, but then...
Don't tell me we had another AI winter.
You guessed it, the 90s were not kind to AI either.
Even with these new neural networks.
Yeah, even with all the progress, they were still facing some pretty big challenges.
So what happened?
Well, funding got cut.
Right.
Again, expectations were lowered.
Ah, the cycle repeats itself.
It does.
Yeah.
But that's what makes the current AI boom even more interesting.
Right, because now it seems like AI is everywhere.
It's inescapable.
So what changed this time?
Well, this time it's all about deep learning.
Deep learning. Okay, that's another one of those buzzwords I hear all the time.
It is, but it's more than just hype.
So what is it then?
Think of it as neural networks on steroids.
Okay, I'm intrigued.
So basically, it's these massive neural networks
Uh-huh.
that have multiple layers,
Okay.
allowing them to process information in a much more sophisticated way.
So more layers, more power.
Basically, yeah.
But I'm guessing it's not just about the algorithms.
You're right, it's not just some magical code.
So what else is going on?
Two other things were crucial.
Hit me with it.
First, the internet happened.
The internet.
Yeah, think about it. The
Yeah.
internet created this massive amount of data.
Oh, I see. So the AI now had something to learn from.
Exactly, all those cat pictures and videos you've uploaded.
They weren't a waste after all.
They're training data for AI.
Wow, so AI is basically feasting on all this data we've been generating online.
Pretty much.
And what was the second thing?
Computing power got a lot cheaper and more accessible.
Right, because those massive neural networks take a lot of horsepower to run.
They do.
Yeah.
And now it's within reach for a lot more researchers and companies.
So it's like the perfect storm.
Exactly.
Oh.
You've got the algorithms, the data, and the computing power.
And that's what's driving this AI boom.
That's a big part of it.
Fascinating.
It is, and it leads us to something everyone is talking about, AI and computer vision.
Right, like AI is now doing things we see every day.
Exactly, like recognizing faces in photos or understanding what's happening in videos.
Like self-driving cars.
That's a big one.
So how is AI doing with computer vision?
Well, one of the most striking examples is this competition called ImageNet.
ImageNet.
Yeah, where computers now classify objects in images
Yeah.
with superhuman accuracy.
Superhuman accuracy.
They're actually better at it than humans.
Wow, that's impressive.
It is.
But I'm guessing there are still some limitations.
Oh, absolutely.
Like what?
Well, Mitchell highlights two key weaknesses,
Okay.
even in these systems that show superhuman performance.
I'm all ears.
One is overfitting.
Overfitting.
Yeah, so it means the AI might be learning the specific data it's been trained on, but not necessarily the underlying concept.
Okay, so it's like it knows the answer, but it doesn't know why.
Kinda, yeah.
Can you give me an example?
Sure, there are these examples where you can trick these AI systems
Okay.
with weird, distorted images that wouldn't fool a human at all.
So it's like those optical illusions that mess with our brains.
Yeah, but in reverse.
The computer sees something totally different than what we see.
Exactly.
That's kind of freaky.
It is a little bit.
What's the other weakness?
It's what Mitchell calls the long tail problem.
The long tail problem.
Yeah, so basically it means that real-world situations are way more varied than any data set.
Right, because you can't possibly capture everything in a data set.
Exactly, even with millions of images.
Right.
You can't anticipate every possible scenario.
So even if an AI is really good at recognizing objects in typical images, it might struggle when it encounters something unusual or unexpected.
Exactly, and Mitchell talks about how this is a big challenge for self-driving cars.
Right, because they have to be able to handle all sorts of crazy situations.
Exactly, and even with all the data they're trained on,
Right.
they can still get tripped up by things they've never seen before.
So it's like even with all this progress, we still have to be realistic about AI's limitations.
Definitely, and it brings up an important question. Even if an AI shows superhuman performance on a test, does that actually mean it has human-level understanding?
That's a great question.
And it's one we should keep in mind as we move on to the next part of our deep dive.
Which is?
AI and games.
Games?
Yeah, games have always been this fascinating test bed for AI.
Right, because they require strategy and adaptation.
Exactly, and often an understanding of your opponent's moves.
So stay tuned as we delve into the world of AI and games.
From chess to Go and beyond.
Sounds fun. I'll see you next time.
See you then.
Welcome back to our deep dive into AI.
We're picking up where we left off.
Last time we were talking about all those different approaches to AI.
Some symbolic, all that stuff.
And how deep learning has really fueled this recent resurgence.
It's been wild to see.
But we also saw that AI can kind of achieve superhuman performance in certain areas.
Like image recognition?
But still struggles with real-world complexity and all those unexpected situations.
The world is messy.
It is. So today, we're going to be tackling what might be AI's biggest hurdle yet.
Ooh, which is...
language.
Ah, yes. The bane of AI's existence.
It's so fascinating to me how we humans use language so effortlessly.
Right, it's like breathing.
Exactly. But for AI, it's a whole different ballgame.
It's like trying to teach a fish to ride a bicycle.
Mitchell actually calls this the barrier of meaning.
Oh yeah, that's a good one.
And it really gets to the heart of why AI is still so far from achieving that true human-like intelligence.
It's like the holy grail of AI research.
So what makes language so challenging for AI? I mean, we communicate with words all the time.
Right, it seems pretty straightforward.
It does.
But it turns out language is much more than just words and grammar.
Okay, so there's more to it than just like syntax and semantics.
Right, it's deeply intertwined with our understanding of the world, our common sense, our ability to grasp these abstract concepts.
Right, and those are all things AI still really struggles with.
Anytime.
But AI has made some progress with language tasks, right?
Oh yeah, definitely.
I mean, we have things like Google Translate.
Right.
And those chat bots that seem to understand what you're saying.
They're getting pretty good.
They are. So is AI getting better at understanding language?
It is. There have been some really impressive advancements.
Like what?
Well, Mitchell points to things like sentiment analysis.
Sentiment analysis.
Yeah. So it's about figuring out if a piece of text,
Okay.
like a movie review, is positive or negative.
Okay, so like, is the reviewer happy or sad about the movie?
Exactly. And it sounds simple.
It does.
But it actually requires understanding nuances and context.
So the AI has to be able to read between the lines.
Kinda, yeah.
So AI is getting better at understanding how we feel about things.
It is.
Based on what we write or say. That's pretty cool.
It is. And machine translation has also come a long way.
Right, like Google Translate.
Exactly. It can instantly translate text between multiple languages.
I use it all the time.
And while it's not perfect,
it's not perfect.
It's gotten significantly better over the years.
It has. I've noticed that.
So yeah, AI is definitely making progress in these areas.
But I'm guessing those are just the tip of the iceberg.
They are.
There must be areas where AI still falls short when it comes to language.
Yeah, for sure.
Like what?
Well, Mitchell shares this funny anecdote about Google Translate.
Uh-oh.
Completely messing up a restaurant bill translation.
Oh, no.
Leading to all sorts of confusion and awkward moments.
So even with all the advancements, AI can still make some pretty hilarious mistakes.
Oh, absolutely. It's not perfect.
And those mistakes really highlight this key point.
Which is?
AI might be able to excel at those surface-level language tasks, but when it comes to deeper meaning and understanding, it often stumbles.
It's like it's missing the forest for the trees.
That's a good analogy.
Thanks.
So this brings us back to that question we've been pondering.
It's a big one.
How terrified should we be of AI?
Right.
If AI can't truly understand language, how can we trust it with these tasks that involve communication, reasoning, decision-making?
That's a huge question.
It is, and to understand the extent of this challenge, Mitchell introduces something called Winograd schemas.
Winograd schemas.
Yeah, what are those?
So they're these seemingly simple sentences that require common sense to understand.
Common sense, AI doesn't have a lot of that.
Nope, not yet.
Okay, so give me an example of a Winograd schema.
Okay, so here's one. The city councilman refused the demonstrators a permit because they advocated violence.
Okay, the city councilman refused the demonstrators a permit because they advocated violence.
Right, so who do you think advocated violence?
The demonstrators, obviously.
It seems pretty obvious to us.
Right.
But computers often struggle with these types of sentences.
Why is that?
Because they lack the real-world knowledge and common sense that we humans take for granted.
So even something that seems simple to us can trip up AI because it doesn't have that same background knowledge.
Right. It's like they're missing the context.
An understanding of the world.
Exactly.
That's wild.
It is. And Mitchell connects this back to our own lives.
Okay. How so?
She's saying, if AI struggles with these basic concepts, how can we rely on it for more complex tasks?
Right, like things that really matter.
Exactly, like writing legal documents, making medical diagnoses.
Or even just understanding a casual conversation.
Right, like the things we do every day without even thinking about it.
It makes you wonder how we can even begin to teach AI common sense.
That's the million-dollar question.
Is it even possible?
Well, that's a question researchers have been grappling with for decades.
Really?
Yeah, Mitchell even mentions this project called Psych.
Psych?
Yeah, it's been trying to build this massive database of common sense knowledge for AI.
Wow, so they're like manually inputting all this common sense into the computer.
Essentially.
Yeah.
And guess what?
Yeah.
It's still a work in progress after all these years.
Wow, so teaching common sense to AI is like a monumental task.
It is. It's one of the biggest challenges in AI research.
So where do we go from here? I mean, we've talked about these impressive achievements of AI, but also its limitations, particularly in language understanding and common sense reasoning.
It's a mixed bag.
It is. So what does all this mean for the future of AI?
That's the big question, isn't it?
It is, and it's one we'll explore in the final part of our deep dive.
Stay tuned. We'll be back.
Welcome back to the deep dive.
It's the final countdown.
It is. We've been exploring the world of artificial intelligence.
All its twists and turns.
Its incredible advancement.
It's mind-blowing, really.
And also its surprising limitations.
Right. AI can be really good at some things and then totally clueless about others.
Exactly like we saw how AI can master games.
Crush those grandmasters.
And decode images with superhuman accuracy.
But then it comes to language.
Oh.
Common sense, abstract reasoning.
It's like AI can solve complex equations, but it can't tell you why a joke is funny.
That's a good way to put it.
Right. And that brings us to this big question we've been pondering throughout this whole deep dive.
The ultimate question.
What does all this mean for the future?
The future of AI, the future of humanity.
Exactly how worried should we be about AI, and what do we need to be mindful of as this technology keeps developing?
A million-dollar question.
They are, and Mitchell doesn't give us a simple yes or no to those questions.
She doesn't try to predict the future.
No, but she does offer this thought-provoking image for us to consider.
Okay, I'm intrigued.
She describes a photo by Andrej Karpathy called the locker room image.
The locker room image.
Yeah, so what comes to mind when you hear locker room?
Sweaty gym clothes, maybe some forgotten deodorant.
Right, exactly. So what's so special about this photo?
I don't know. You tell me.
Well, at first glance, it seems like a pretty ordinary scene, right?
Okay.
But Mitchell points out that it's actually full of things that AI systems can't quite grasp.
Oh, really? Like what?
For example, there are people in suits in the locker room.
People in suits in a locker room. That's kind of weird.
It suggests something out of the ordinary is happening.
Like maybe it's not just a regular locker room.
Right. There's a deeper context that the AI might miss.
Okay, I see.
The photo also shows Obama's foot subtly resting on a scale.
Wait, Obama's foot is on the scale?
Yeah. Yeah, messing with the weight reading.
Oh, that's funny.
It is. And we as humans can predict how the person on the scale will react when they see that inaccurate number.
Right. We understand the humor of the situation.
Exactly. We understand the social dynamics, the physics of what's going on.
It all makes sense to us.
Right. But AI might be able to identify all the objects in the image.
Like you can see the scale, the foot, the people.
But it doesn't really get the whole picture.
Right. It's missing that deeper level of understanding.
Exactly. And that's a key takeaway for our listeners.
Okay, what's the takeaway?
General AI, the kind that could truly understand and interact with the world like a human. It's not right around the corner.
We're not all going to be replaced by robots tomorrow.
Yeah. Not tomorrow, no. But that doesn't mean we should be complacent.
So we shouldn't panic.
We shouldn't panic.
But we shouldn't ignore AI either.
Exactly. Narrow AI, which is really good at specific tasks,
Right.
is already incredibly powerful. And it's being used in more and more areas of our lives.
It's everywhere.
It is, and that brings us to some real-world concerns that Mitchell highlights.
Okay. What are we worried about?
Well, it's not just about robots taking over our jobs or becoming self-aware and deciding to destroy humanity.
Right, those are the Hollywood scenarios.
Exactly.
But what about the real stuff?
Yeah, there are some more immediate and practical concerns that we should be thinking about.
Like what?
Well, one concern is AI bias.
AI bias.
Yeah, so if AI systems are trained on biased data, they can perpetuate and even amplify those biases in their decisions.
So if the data is bad, the AI is going to be bad.
Basically, yeah, and this has real-world consequences.
Like what?
Well, imagine an AI system being used for loan application. And it's been trained on data that shows this historical bias against certain groups of people. That AI system could end up denying loans to those people unfairly.
Simply because of their background.
Exactly.
That's not right.
It's not, and it's a real concern.
So what can we do about it?
Well, that's a big question that a lot of researchers and policymakers are trying to answer.
Uh-huh.
It involves being really careful about the data used to train AI systems.
Right. Make sure it's representative and fair.
Exactly.
Are there other concerns aside from bias?
Yeah. Another big one is explainability.
Explainability.
So as AI systems are making more and more decisions that impact our lives, from loan applications to medical diagnoses.
Right, these are big decisions.
We need to be able to understand how those decisions are made.
Like we need to be able to look under the hood and see what's going on.
Exactly. If we can't understand how an AI system is making decisions, we can't hold it accountable.
Right.
Or ensure that it's being used fairly and ethically.
It's a black box.
It is, and that's a problem.
So it sounds like there's a lot to consider as AI becomes more integrated into our lives.
There is. It's exciting
Uh-huh.
and a little bit scary.
Definitely.
But Mitchell argues that understanding AI's limitations can also teach us about ourselves.
Oh, that's interesting. What do you mean?
Well, by studying what AI can and can't do, we can gain a deeper appreciation for what makes human intelligence so unique.
Like what sets us apart?
Exactly. Our ability to think critically, to reason about the world, to connect with others through language and shared understanding.
Right. Those things are special.
They're things to be cherished and nurtured.
Absolutely.
So as we wrap up this deep dive into the world of AI,
It's been a wild ride.
it has. I want to leave our listeners with a thought-provoking question.
Okay, hit me with it.
Mitchell doesn't think general AI is imminent.
Right, like the Terminator scenario.
Exactly, but she doesn't rule it out entirely either.
So there's still a chance.
There is. So here's the question. What would AI need to achieve to make you truly terrified?
Ooh, that's a good one.
Or maybe truly excited?
Right, like what's the tipping point?
Exactly. Would it be the ability to understand and respond to our emotions?
Like a truly empathetic AI.
Or create art that moves us?
AI-generated masterpieces.
Or maybe solve complex scientific problems that we've struggled with for centuries?
Like curing cancer or solving climate change.
Exactly. The possibilities are vast.
And maybe a little bit scary.
They are, but they're also incredibly exciting. We encourage you to explore those possibilities, to engage with this rapidly changing field, and to contribute to the conversation about how we shape the future of AI. Thanks for joining us on this deep dive.
It's been a pleasure.